Good morning, children. Today we will study about thermal expansion in fluids. Fluids means liquids and gases. You have been taught about expansion in solids so far, and you observed three types of expansion: linear expansion, superficial expansion, and cubical expansion. You were also taught about the formula to calculate all these three types of expansions. Apart from this, you are also aware of the relationship, mathematical relationship that exists between alpha, beta and gamma, which is 1:2:3. One of the most important consequence, or you can say the characteristic that we observed during the study of thermal expansion in solids is that the different materials expand differently. It is just because that every material has different coefficient of expansion. Copper will have different coefficient of expansion as compared to brass, aluminium and so on. And based on this particular property, bimetallic strips are designed. Apart from the bimetallic strips, some more applications and illustrations that exist in our daily life, that we observe in our daily life related to thermal expansion, were also explained to you. So now let us begin with expansion in liquids, and then we will move on to expansion in gases. Now liquids do not have definite shape. So liquids have only cubical expansion. So here is a slide in which you can see the molecules of liquids are arranged in this way when the temperature is low. And as you can see, the intermolecular space between these molecules is also low because it is at a lesser temperature. Now on heating, what do you observe in this figure? You must have seen that the gap between the molecule has increased. Why? Just because when these molecules absorb heat energy, their kinetic energy also increases and they are able to overcome the force of attraction. Because of the increase in kinetic energy, the molecules vibrate vigorously, which increases the distance between them and hence the volume. Here there are certain important points related to expansion in liquids. Since the intermolecular space between the in liquids in liquid molecule is more than that of solids, therefore the expansion in liquid is more than that of solid. That means they expand more and beyond their original level. In the beginning of this lecture, you have been shown some experiments, some demonstrations. And in one of those demonstrations, you witnessed that the expansion in alcohol was much more than that of copper sulfate solution, which was even more than water. That means if you compare the level of expansion between copper sulfate solution, water and alcohol, you will find, or you must have noticed, that the expansion in alcohol was maximum. This is because different liquids have different coefficient of volume expansion. Just like solids, every solid has different coefficient of thermal expansion. In a similar way, liquids also have different coefficient of volume expansion. And in this figure, the same property is depicted. Here you can observe that there are 4 liquids in the hot water bath. And Out of these four liquids, ether expands the most, then benzene, then ethanol. Ethanol is one liquid, one sort of liquid, and the minimum expansion is shown in water. So this is why is this happening? Just because the coefficient of expansion of ether, the coefficient of expansion, which one? Volume expansion. The coefficient of volume expansion of ether is maximum and that of water is minimum. So which means that the greater the coefficient of expansion, the more will be the expansion observed in the liquid. Now there are some applications that we observe related to expansion in liquids. And one such application that we find in our daily life is the anomalous expansion of water. So what is this anomalous expansion mean? Children, you have been told just now that when you heat up any substance, the substance will expand, and when it is cooled, the substance will contract. But there is an exception. There are certain substances like water, when they are heated within a certain range of temperature, they contract, whereas they expand on cooling, and water is one such substance. Other substances that show the same behavior is silver iodide and silica. So this peculiar behavior of water is known as anomalous behavior. So it has been found that when you decrease the temperature of water from 4 degrees Celsius to 0 degrees Celsius, that means if the water is initially at 4 degrees Celsius and you are cooling water, that means you are bringing the temperature of water down to 0 degrees Celsius, then ideally water should expand. Sorry, water should contract because you are cooling the substance. But what will you observe here? That water will expand. On the other hand, when you have water at 0 degrees Celsius, that means you have water in the liquid state at 0 degrees Celsius and you heat it up and you raise the temperature of water, then ideally what should happen? Water should expand, but now water will contract. Beyond this range of temperature, water will experience normal expansion. That means beyond 4 degrees Celsius, if you heat it further, 5 degrees Celsius to 6 degrees and so on, you will find that water is expanding. But in this particular range of temperature only, water shows unusual behavior. And that is why this is known as anomalous expansion of water within the temperature range 0 degrees Celsius to 4 degrees Celsius. This particular behavior of water helps the marine life to survive in cold weather in cold countries. Because of this particular property, the water helps uh, sorry because of this particular property, the upper layer of water freezes. The upper layer of water freezes and its temperature remains at 0 degrees Celsius, and all the aquatic and marine life can survive easily below this frozen surface, and the water which is below this frozen surface is at 4 degrees Celsius. So all the aquatic creatures remain alive in water in the pond or the lake in winter season in the cold countries. So this is anomalous behavior of water. Now here there are two more pictures depicting the application of liquid expansion in our daily life. Now medicine bottles are never filled up to the brim. There is always some space left in all these liquid bottles, whether it is a medicine bottle or you have seen any cold drink bottle also, that there is always some gap left. This is the space allowed for expansion. If the liquid expands, then there is space provided, and in this space the liquid will expand. Based on thermal expansion, the concept of thermometer is based upon. There is mercury or alcohol in the thermometer. So when the body is cold, the mercury or alcohol contracts. When the body is warm, then the mercury or alcohol expands. So these two are some more examples or applications of expansion in liquids in daily life. Next we come on to gases. Gases also do not have any shape or size. Therefore, only cubical expansion is possible in gases. Now, in gases, at normal temperature itself, the molecules are free to move. That means the intermolecular space between the molecules is quite large enough. And when they are heated, this gap becomes even more. And hence, the expansion in gases is maximum as compared to liquids and solids. In gases also, these molecules vibrate vigorously on heating. They push each other, they collide with each other, their kinetic energy increases, and which in turn increases the space between the molecules, and therefore the volume increases. Now let us see some of the applications of expansion in gases in our daily life. This picture depicts the bursting of tire that takes place in summers. Why? Because the air inside the tire expands on heating and it bursts. Hot air balloon. The gas which is filled in this balloon expands on heating. So these are the two examples or applications of expansion in gases in our daily life. There are some more applications related to expansion in gases as well as liquids, which you will find around you. So let us summarize all the points. When a substance absorbs or loses energy, heat energy, the movement of the particle is affected, which causes its volume to change. So when you are heating the substance, the particles, the movement of the particles increase, volume increases. When you cool a substance, the movement of the particle decreases, and therefore the kinetic energy decreases and the volume decreases. All three states of matter expand on heating and contract due to cooling because of this movement of the particles only. However, among solids, liquids and gases, gases are the ones which contract the most as well as expand also the most among all the three. Temperature changes affect volume of gases the most. This is what is explained in this point. And based on the expansion in solids, liquids and gases, there are many applications or practical or safety considerations associated with expansion and contraction are present in our daily life.